Chapter 8 begins our lessons on volume and surface area. Lesson 1 will be specifically talking about the volume of cylinders. Now, in case we do not remember, a cylinder is a shape created when you have two circles on each end, and then you draw two parallel lines along the side. Some examples of cylinders you already know would be, say, a soda can. We would be talking as an example, about finding the volume of, say, a can of soda or a can of soup or a water bottle, all sorts of different examples of what a cylinder is. And we'll break down what this equation down here means. To start, what is volume? Now, volume is a topic that you talk about in both math and science classes. Volume is simply the measure of space occupied by a solid. And we measure that in cubic units. The reason why we're talking about cubic is we live in what we call three-dimensional space: length, width, and height. Well, if we have length times width times height, because we multiply for area, that's units times units times units, which simplifies to say units cubed. So that is what we're working with. Volume is how much space an object takes up in our world. How much space, say, I have a can of soda in front of me, how much space does that soda can actually take up? To get started, let's talk about how we can calculate that volume. So, volume, we will use the letter V, the capital letter V. The volume of a cylinder with the radius R is the area of the base, which we're calling capital B, times the height H. So we have the equation V equals the base area times the height. The part you have to know is what is the area of that base. So we go to the example of a cylinder. And for a cylinder, the base is actually a circle. And the area of a circle is found with pi times r squared, as we see written here. So I would go, and in my equation for volume, V is equal to, well, the base area is pi r squared. And we're going to multiply that to the h from the equation. And that gives us how we're going to find each of our calculations. You will need a calculator in order to do this correctly because of the use of the pi button. Let's take a look at some examples so that you have some guidance when you try this on your own. Find the volume of the cylinder, round to the nearest tenth. I get asked almost every lesson, am I supposed to round this? Well, the directions are always written there, and they tell you round to the nearest tenth. Now, for the volume, we know we're using the base area times the height. For this example of a cylinder, the base area is pi r squared, and the height is actually given to me in the picture. That height is this straight side of 8.3. But what is this segment here that goes only halfway across the circle? That is the radius. So when it comes to a circle, what we need to remember is when I have a segment that goes from the center to the edge, this is called a radius. And now I can go in and fill in each part. So the volume is equal to, well, the base area is pi times r. What am I replacing r with? I'm replacing r with the 5 for my radius. Do not forget your exponent. And then the very last part is the multiply by h. So I'm going to multiply by 8.3. I suggest whenever possible to go ahead and simplify anything that you can at the beginning here, such as this 5 squared. We are familiar with 5 squared. We know 5 squared is 25 times 8.3. From here, you must go ahead and multiply everything in your calculator. I might suggest we do numbers first. So 25 times 8.3, I get pi times 207.5. And now I've finished by multiplying by pi. Now you know pi to be 3.14. We're going to go ahead and use the pi button on your calculators. What you'll do is you'll type in 207.5 times, and then you have to go ahead and get pi. Different calculators have different methods. If you have a TI calculator, you must hit your second I apologize. I'm actually going to back that up. I'll put that separately on any post I make. But I'm going to go ahead and multiply. So times pi, I get an answer of 651 point. Well, my calculator says 0.88. But I am only supposed to round to the nearest tenth. So that's one decimal place. So instead of 0.88, this will become 0.9. Because 8 tells me to round up. Now for my units. This whole time I've been multiplying by centimeters. But since I'm talking about volume, it is centimeters cubed. our second example. This time we don't have any sort of picture, so let's see what's happening. It says the volume of a cylinder with a diameter of 16 inches and a height of 20 inches. Round to the nearest tenth. What we need to be careful of is when we talk about diameter. So first off, to give you an idea of what we're talking about, I have a cylinder with a height of 20 inches and a diameter of 16 inches. So notice that for diameter, I took that line from edge to edge of the circle. We need to recall that on a circle, starting with the center, if I have a line that goes from edge to edge, that is called diameter. When I have a segment that is from the center to the edge, that is the radius. So we have to do a little bit of extra math on the side. Something to know is that the radius is equal to half of the diameter. And we're going to need that anytime I'm talking about circles, especially with volume. We need to know what that radius is more than I need to know what the diameter is. So let's begin. Volume is equal to base area times the height. I know that the height is 20 inches. I need to figure out the base area. Well, for the base area, I need to know what that radius is. So let's see. I have a diameter of 16. The radius is equal to 1/2 the diameter. So that's 1/2 times 16, which is 8. So the radius is 8. And now I can go ahead and piece this together. The volume is equal to pi times r squared times the height. We know that 8 squared is 64. I'm going to start with multiplying my two numbers, 64 times 20. That is 1,280. I put this in the wrong order. Now I need to multiply by pi in my calculator, and I get an answer of 4,021 point. Well, it says 0.23. If I need to cut it off at the 2, the 3 means I round down, so I'm going to stay at 2. My unit is inches. And again, for volume, I'm talking about cubed. So this problem demonstrated one step we didn't use before, and that's knowing the difference between radius and diameter, and knowing how to take the diameter and get your radius. Example 3. A metal paperweight is in the shape of a cylinder. All right, so again, working with the same shape. The paperweight has a height of 1.5 inches and a diameter of 2 inches. How much does the paperweight weigh if 1 cubic inch weighs 1.8 ounces? I'm going to need that. That's actually going to be an extra piece that we're going to add to this problem. So not only are we going to find the volume, but then we're going to take that volume and use it to solve one step further. So this paperweight has a diameter of 2 and a height of 1.5. Remember, I need the radius, which is 1/2 the diameter, and 1/2 of 2 is just 1. So my radius is 1. Again, volume is equal to base area times height. My height is 1.5. So let's go ahead and begin solving. Volume is equal to pi times r squared times the height. Well, 1 squared is just 1 times 1.5. That's equal to pi times 1.5 for a volume of 4.71, which rounds to 4.7. But am I done? I am not complete with this problem. Remember, I want to take the volume and turn it into the weight. And we have a way of doing that. The weight has a scale factor here of 1 cubic inch. One cubic inch is 1.8 ounces. I want my answer to come out as ounces. So 1 to 1.8. Remember, new divided by old. Well, my new is going to be the 1.8. So that's going to go on top. The old is where I'm starting. That's the 1. I need to take the volume and multiply it by that. So we must solve 4.7 times 1.8 over 1. And that will tell us what our answer is. So this is combining what we've already done to something that we are learning now. 4.7 times 1.8 over 1 gives me an answer of 8.46. So I got to back up. That 6 tells me to round the 4 up to 5 ounces, because that is the unit they wanted me in. So a little bit extra. The main focus right now is the part about finding the volume. But you never know when you're going to be asked to use that for one more step. Last thing is going to be on what's called composite solids. Composite solids are objects formed using more than one type of solid. It's combining two shapes. We're going to look at one example. Tanya uses cube-shaped beads to make jewelry. So you know that with a bead, there's a hole in the middle. Each bead has a circular hole through the middle. Find the volume of each bead. So let's talk about what shapes are here. I have a cube, and I have a cylinder here in the middle that is that hole, that circular hole. Well, if I want to find the volume of the bead and that cylinder is a hole, then I'm going to have to take the volume of the cube and subtract out of it the cylinder. Again, we are using subtraction because the cylinder is a hole in the bead. When talking about a cube, we have a volume. So the volume of the cube of length times width times the height. For the cylinder, which is what this chapter focuses on, we know it's base area times the height. In this case, we got to go back to the picture and note something. This is a cube, meaning all sides are the same. So the height in this image is 12. For the cylinder, the 2 is a diameter. So remember that the radius is 1/2 the diameter. So that is 1. And now we can start piecing together our problem. The cube, which is length times width times height, is 12 times 12 times 12. Which is 1,728. The volume of the cylinder is pi times 1 squared times 12, which gives me an answer of 37.7. So now I have my two volumes. And what was I supposed to do with those volumes again? Well, to find the volume of the bead, it's the cube, and I'm going to take away from it the cylinder. So for the final volume of the bead, I must take volume of the cube, subtract the volume of the cylinder. Let me go ahead and substitute those in. 1,728 minus 37.7, which gives me a final answer of 1,690.3. Again, it's volume. I'm talking about everything in millimeters, so millimeters cubed.